Hi everyone! Today I'm going to tell you about the period of Islamic hegemony in mathematics, the golden age of Islam during which science and culture flourished. Somewhere in the 570s, Muhammad was born in Mecca. Muhammad became a merchant, caravaner, and so he traveled a lot, including Palestine. He communicated with Jews and Christians, and so, because of his deep religious feelings, it led him to the belief that he was the apostle of God, sent to lead the people. At that time, Arabia was inhabited by pagans, polytheists. Muhammad started to spread a new faith, but not all polytheists wanted to accept a new religion, and thusly the Muhammad's military career began. After winning many battles, and I would like to mention that, according to Muslims, he won these battles thanks to the angels. Angels appeared in the Battle of Badr and helped him to win. Because pagan warriors outnumbered Muhammad's forces, nevertheless, he was able to win. He defeated all the pagans in Arabian Peninsula and gained a foothold in Mecca. He founded a new state with a new monotheistic religion within which Jews and Christians were afforded protection and freedom of worship. In the year 632, while planning to move against the Byzantine Empire, Muhammad died in Medina. But the followers of Muhammad continued their conquests and began to spread Islam further and further into the depths of the continent. But I need to mention that it was not a single empire, but rather several fairly large kingdoms, and often they were fighting each other. And so Muslims started absorbing the learning of the civilizations they had overrun. Unfortunately, during the conquest, lots of books were lost. In order to restore and save some of the knowledge, to Baghdad were called scholars from Syria, Iran, and Mesopotamia, including Jews and Nestorian Christians. Under three great Abbasid patterns of learning, Al-Mansur, Haroun al-Raschid, and al-Mamun. One day, the Caliph of Abbasid Caliphate, Al-Mamun, is said to have had a dream in which Aristotle appeared, and so Al-Mamun decided to make Arabic versions of all of the Greek works he could get his hands on, including Ptolemy's Almagest and a complete version of Euclid's Elements. He wanted to translate all the ancient Greek manuscripts. I want to translate all of them, you know? So from the Byzantine Empire, with which the Arabs maintained an uneasy peace, Greek manuscripts were obtained through treaties. And so Al-Mamun established in Baghdad a house of wisdom, comparable to the ancient museum in Alexandria, which was accidentally burned by Julius Caesar during a civil war. Major emphasis from its beginning was placed on translations, initially from Persian to Arabic, later from Sanskrit and Greek. The House of Wisdom, which gathered the old Greek books' translations, allowed the birth of many Arab scientists and philosophers, some of which you clearly know, like Avicenna or Amar Khayyam. But one of the greatest Arab mathematicians is, of course, Muhammad ibn Musa al-Khwarazmi. He wrote more than half a dozen astronomical and mathematical works. The scheme of numeration that made use of the Hindu numerals came to be simply called algorithm or algorithm, a word that originally derived from the name Al-Khwarazmi. It's because of him, He took the Hindu numerals and the new notation system for the numbers for his works. He also wrote a book about algebra dedicated to quadratic equations and some principles for their solution. He was using a completion of square technique to solve the equations. It was revolutionary, because in the past people used geometrical form on how to solve these equations, but they didn't use algorithms using variables. For example, he used the symbol x to represent an unknown quantity in an equation, and then he would manipulate the equation to find the value of x. His approach to solving equations became the basis for modern algebraic notation and laid the foundations for the development of algebra as a field of study. Of course, he also showed the solution using rectangles and squares, like in ancient Babylonia, but he also started to use some sort of variables. Muslim scientists that were translating Greek books were also working on alternative proofs of the Pythagorean theorem. They were working on parabolic and paraboloidal segments, discussed magic squares, angle trisection, and the new astronomical theories. I need to mention that the Arabian science was flourishing also due to the introduction of madrasa system. It's a type of education institution that was free for all the Muslims, and it was sort of a secondary education, almost like a college. Of course, it was strictly related to the Islam religion. It wasn't secular, but it was a great benefit over the Europeans that didn't taught people this way. But one of the most important things is that Arabic scholars popularized and introduced to the Europeans Hindu numbers that now we call an Arabic ones. You can clearly see that over time symbols for digits have changed, and only from 15th to 16th century we came to the modern ones that we use to this day. There is a common misconception that the Arabic numbers were based on the number of angles of the particular shape. But it is not true! The shapes of the Indian numerals are not based on the number of angles they contain, but rather they have evolved over time from the ancient Brahmi numerals, and their shapes are influenced by cultural and historical factors. The trigonometry. The second great thing that Muslims introduced and popularized among the Europeans is trigonometry. It was developed mainly through astronomy, when Arabs tried to measure the distance from the Earth to the Sun or to the Moon using right triangles. And you'll need to introduce all of these trigonometric functions in order to calculate it. Therefore, astronomy gave a major thrust to the development of trigonometry. Arabic trigonometry was ultimately built on the sine function. It was again through the Arabs rather than directly from the Hindus that this trigonometry of the sine reached Europe. Sometimes attempts are made to attribute the functions tangent, cotangent, secant, and cosecant to specific times and even to specific individuals, but this cannot be done with any assurance. To some extent, the development of trigonometry is due to the Islam. I mean, to build a mosque, you need to know where Mecca is located, and so the Kaaba. You need to calculate so-called Qibla, the direction towards the Kaaba, in the sacred mosque in Mecca, which is used by Muslims in various religious contexts, particularly the direction of prayer for the Salah. I need to point out that this is a modern picture. Indonesia was discovered only by the Ottoman explorers near the 16th century, but we are talking about the period from 8th to 13th century. It's just a fancy picture. So geodesy in Islamic countries developed well because they needed to calculate in which direction they needed to pray. One of the greatest geodesists at that time was Al-Biruni. He made a lot of inventions in geodesy, some of the concepts we use even to this day. Al-Biruni also contributed to physics. Omar Khayyam, a famous Arabian philosopher, was also deeply interested in mathematics, and he managed to understand how to solve some specific sorts of cubic equations. He used coordinate axes long before Descartes, but he used them only to solve the cubic equations. Omar Khayyam also came to the so-called Pascal triangle. Around the same time it was discovered in China, but we don't really know who was the first. So now we can say that Islamic mathematicians were clearly more attracted to algebra and trigonometry than to geometry. The Muslim science declined by the 13th century. One of the reasons was that during the Mongol invasion of Baghdad, the library of the House of Wisdom was destroyed. This time, books were not burned, but thrown into the river, which was equally effective, because water quickly washed out the ink. Unfortunately, I cannot tell you about all the discoveries of the Muslim scientists during the golden age of Islam, but I hope that this brief presentation has given you an overview and you would like to read more about this topic. Thanks for your attention!